Today's farmers are tomorrow's heroes. That's because regardless of the country or farming region, feeding a population that could reach 10 billion by the year 2050 presents enormous challenges to the agricultural community. Plant production must increase 60 to 100% to keep pace with the current food waste levels, population trends, and food consumption. Food producers must successfully grow more crops while enacting strategies to conserve and build soil resources in order to minimize agricultural impacts on the environment. Technology will play a key role in balancing the need for increased yield with environmental preservation. The USDA has developed a public-private partnership with major players in the industry to more quickly deliver new science to farmers who in turn can deliver valuable data back to the scientists. USDA is providing an open platform called the Agricultural Collaborative Research Outcomes System, or AgCROS, to facilitate the development of new technologies that will directly benefit the farmer. Let's take a quick tour of one of AgCROS's projects that focuses on improving science around cover crops, which can be used as a natural carbon sink for dealing with climate change. At the Beltsville Agricultural Research Center in Maryland, scientists and engineers are using research farm fields to test out new technologies to easily capture data from fields that can be used to calibrate remote sensors from drones or satellites. But we all know farmers are busy people, so we need a better way to capture data. What if you could just tell your cell phone what data should be captured? That's exactly what technologies from AgVoice are doing to not only capture data, but provide value back to the farmer to help improve yield. Here we see the results of a farmer walking around the field and leaving breadcrumbs of data on the quality of the corn that he observed. While AgVoice is a tool that immediately helps the farmer, another approach to capturing data is to use a robot equipped with sensors to estimate yield and crop health. Here's the track of the robot moving across the same field, capturing breadcrumbs of data that can be used in conjunction with data captured from AgVoice. This data can be used to feed into a dashboard that displays key properties about a farmer's field. Viewed through Esri's dashboard technology, Microsoft's FarmBeats aggregates data from devices like AgVoice, EarthSense, and soil sensors in the ground to give a farmer a real-time and remote view of their farm's health. Of course, another way of viewing crop health is to look at the amount of biomass as it varies in a field, since biomass is an indirect indicator of yield. We can capture biomass data directly from a highboy tractor that carries a sensor that captures the amount of biomass at a particular location. From the tractor path, green areas indicate high biomass, while red areas indicate low values. This data, coupled with other data from sources like AgVoice, can be used to inform the farmer on what actions can be taken to improve yield. But we can also use satellite data as an estimate of biomass. And we can use all the mentioned data sources like AgVoice to calibrate this data to ensure accuracy across the field estimates. For example, we can use the Israeli satellite Venus, which has been specifically designed for agriculture. Of course, all of this depends on not having clouds over your field, which is not the case as we zoom to our field of interest. In order to look at the overall biomass across all fields at the Beltsville, Maryland farm. Again, high biomass is in green, while red areas indicate low or no biomass. Finally, all of this data, including those captured from sources like AgVoice, can be used to feed into machine learning algorithms that can classify the state of agriculture, not only helping the local farms, but the broader farming community.